Everyone, this is Rodney. So today this is a continuation from last time talking about difference between vector and the matrix. If you haven't checked that, I hope you check on that. You can go to either right upper corner or the description to know this series. Also, you can check the AM fundamental playlist in my channel where more basic knowledges will be provided. Although we are not going to make anything productive, but I think knowing fundamentals will be helpful for actual tutorials later on. So let's start. So the next topic is about the further application of vector and the matrices. And this is a very easy setup that I've shown you earlier, that you just distribute objects over a grid that has been generated by these nodes. Or you can just change that to circle or spiral or whatever you want. And again, the vector has only the control to location. But of course, the scale is also vectors, but it's very pointless if you plug this vector into scale, because it contains 0 values. So all the cubes will basically just crush with 0, y, or z, or whatever numbers. So it's just kind of idea. So usually you just plug this vector to location, even if the scale is also vector, and even if you can convert the vector to Euler number so that to rotate everything. But it's just pointless. The good part of using vectors is that you can easily use vector math or Euler math to control all these kind of things. And if you're using matrix, things will be very unintuitive. So let's just move everything away and let's use our matrix instead. And let's plug this matrix into matrix. So now I have a grid. So there are several ways to move everything. One way is to use offset matrices. I think this is personally the easiest way, and you will know why. So if I'm using these offset matrices, then I'm offset everything based on these matrices. So basically, if I move them, I can also rotate them. I can also scale up and down. It's basically another form of object transform output. A very good part is you have a fourth control over that, so you can use a fourth to define whether they actually translate as it has been. If you have watched my other tutorials, probably understand what the fourth means and how it works. So basically, a fourth range will define whether it will change as suggested by these nodes or not. But sometimes I would just but sometimes if your whole point is just to easily add or minus number, then I think you don't need to consider this fourth at all. There are some other ways, of course, and here it comes to be a transform matrices. And that's why I don't usually like this method, because you need to generate one more node to define the transformation. So in that case, let's just compose matrices and connect it to that. And if I add a translation, it moves as it is, but some difference will come later, as you will see. So if I'm adding the rotation, then you can see everything rotate as a whole. So what happens earlier, you can see objects has been rotating individually instead of as a whole. But by using these transform matrices, then everything rotate as a whole, and actually they will scale as a whole as well. So this is kind of very interesting note. And there is also another method. Another method is just to use matrix math. This matrix math sounds to be very confusing because it only has one operation of multiply instead of having many other options like add, subtract, multiply, blah 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 blah, blah stuff. And let's just see how it works. It might be easier to see how circle works. So now if I connect everything with the transform matrix, as you see, it just rotates as a whole. But if you're using the matrix math method, then everything will rotate individually. So in this case, you can see how they rotate individually and generating kind of interesting pattern. And let's plug these matrices to see if we can actually get the same result. It's basically the same. So sometimes I prefer offset matrix over the matrix math and transform matrix so that I don't need to generate additional nodes for certain functions. So this part I finished talking about how to use matrix properly. And just for additional information, there's also nodes called offsets vector. In this case, it has similar functions. So that's it. I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.